Hello everyone, I'm Marcus S. Allen. Welcome back to SMA Academy. Today we have an interesting algebra question and the course is Math 100. The topic is finding the roots of an equation. The question says, given that z cubed minus 1 plus 4rz squared minus 3, parenthesis will be 1 minus 3rz squared plus 14 minus 2r is equal to 0. Where z is the element of a complex number. Find the three solutions of the above equation, given that one of these solution roots is purely imaginary. So look at the equation above. This equation is a complex equation. A complex equation where we have an imaginary and another real number solution. The question says that z is an element of a real number, a complex number. So z is an element of a complex number, meaning that z is equal to x plus y. Z is a complex number such that z is equal to x plus y, where x is a real number and y is the imaginary number, Rm. The question says that one of these solutions is purely imaginary. So if the solution is purely imaginary, means that the real number is 0. So we have z is equal to 0 plus yr. So z is equal to yr. So now our complex number is equal to what? Z is equal to yr. So looking at the equation says x cubed minus parenthesis will be 1 minus 1 plus 4r z squared minus 3 parenthesis will be 1 minus 3r z plus 14 minus 2r is equal to 0. But we realize that the value of z, which is a complex number, is not equal to yr. So we replace, and what we see is there, we replace by what? Yr. We will have yr raised to the third power. Minus parenthesis will be 1 plus 4r. And what we see there, replaced by yr raised to the second power. Minus 3 parenthesis will be 1 minus 3r. And what we see there, replaced by yr plus 14 minus 2r is equal to 0. We can simplify. Y raised to the third power is y cubed. And I raised to the third power is r cubed. Minus. Again, simplify. Parenthesis will be 1 plus 4r y squared. Y raised to the second power is y squared. And r raised to the second power is r squared. Minus, we will multiply the 3 by parentheses. We have minus 3. This and this is 3. This and this is minus 9r. Multiply by y plus 14 minus 2r is equal to 0. Again, from complex number, we realize that the square root of minus 1 is equal to r. So r squared is equal to minus 1 and r cubed is equal to minus r. Why? Because r cubed is equal to r squared times r. And r squared is what? Minus 1. So minus 1 times r is minus r. So we replace. And what we see r squared replaced by minus 1. And what we see y cubed replaced by minus r. So we will have y cubed. And I will see R cube replaced by minus R. Minus. Parenthesis will be 1 plus 4R y squared. And obviously R squared replaced by minus 1. So I have minus 1. Minus 3 minus R plus 14 minus 2R is equal to 0. So we multiply. Y cubed times minus R is minus Y cubed R. Again, negative times negative is positive. Parenthesis will be 1 plus 4R y squared. Again, we have minus, parenthesis will be 3 minus R y R plus 14 minus 2R is equal to 0. We can multiply by this in the parenthesis and this also. So we have minus y cubed R plus y squared by the parenthesis we have y squared times 1 is y squared. Y squared times 4R is plus 4y squared R. Again, this time this, the negative multiplied by this. So negative times 3 will give us negative 3 and negative times minus 9 will give us positive 9. So if we multiply it by y, we'll have minus 3 YR. Again, we'll have plus 9 YR squared because R times R is R squared plus 14 minus 2R is equal to 0. So we can reduce our value of R squared and our value of R cubed based on our condition where R squared is minus 1 and R cubed is minus R. So we simplify by saying minus Y cubed R plus Y squared plus 4Y squared R. Minus 3 R squared is minus 1, so we have minus 9Y plus 14 minus 2R is equal to 0. So as we said that a complex number is equal to the real number or the real part of the complex number plus the imaginary part of the complex number. So x is equal to x plus y. So we can group our real number and we can group our imaginary number. And we said that our real number, a number such that there is no r. So we can group all our value that don't contain r. So our value here is y squared. We put parentheses also y squared. Our next is minus 9y and our next is plus 14. We say plus r. We group our imaginary, so we have our one imaginary which is minus y cubed. We have another imaginary which is this plus 4y squared. Another imaginary which is minus 3y. Another imaginary minus 2 is equal to 0. So we try to rearrange this by looking at this is a quadratic equation. So we have to see if this quadratic equation is factorable. So to know how to factor a quadratic equation, you have to look at the constant term. The constant term is 14. So you ask yourself, which number, if you multiply, you have positive 14. If you either add or you subtract, you have 9. So we realize that you form y minus 7 and y minus 2. Because minus 2 times minus 7 is positive 14. And minus 2 minus 7 is what? 9. Plus r. So check this out. So we have minus y cubed plus 4y squared minus 3y minus 2 is equal to 0. So have this. So we have this cubic equation. So the factor of cubic equation, this is a cubic equation in this parenthesis. So the factor of this cubic equation, we can use a principle that says the factor of the constant divided by the factor of the linear. So we realize here our constant from this cubic equation is minus 2. So my constant here, C, we take as constant, is minus 2. And our linear L, which is minus 1. So we found our factor, which is our greatest common factor. So our greatest common factor for this guy is minus 1 and that over minus 2. And the greatest common factor for this is just minus 1. So we take our equation such that we have a factor divided by the linear. So we take this as 1 and 1. 1 divided by 1, we have positive 1. So we first check to see if positive 1 will work with this equation. So positive 1, if we replace, we see y by positive 1. Now we replace y by positive 1. So we will have this guy which is minus 1 because we put positive 1 raised to the third power 1. 1 times minus, we get negative. So also put positive 1 here, we have positive 4. Also put positive 1, we have minus 3. We also put positive 1, we have minus 2. So we try to see if equal to 0. Because we want for this to be equal to 0 in order for one of the factor to be a solution. So we want this, if this is equal to 0, it means the number that tested the equation is a factor of the equation. So we simplify by saying this from this is what? It's positive 3. So positive 3 minus 3 is 0, minus 2 is minus 2. So this fail. The next one we test is this constant divided by this. So we have minus 2 divided by minus 1 is positive 2. So we test by positive 2. So then we'll see why for positive 2. So for positive 2 in here, we will have minus 8. Because 2 raised to the third power is what? Is 8. So 8 times minus this is what? Minus 8. Again, we have this. If we put y, we put 2 here as y squared, we have 4. 4 times 4 is 16. So we have plus 16. Again, if we put 2 to this, we have 3 times 2 is 6. So it's minus 6, minus 2. So we can simplify. The sum of this is minus 8, and minus 8 is minus 16. Minus 16 plus 16 is 0. So we realize that 2 was a test of this equation. So if 2 is a test of this equation, meaning that x was equal to 2. Meaning that y was equal to 2. Because we use 2 to test the equation. We already have our first factor, which is 2. So if is y equal to 2, it means that y minus 2 should be equal to 0. So y minus 2 equal to 0 is one factor. So to find the remaining factor of this cubic equation, we use our analysis called long division or syntax division. So we let's use syntax division. Syntax division says that we look at the body here. The body here is 2, right? With the first factor. So we take 2. Our value is 2. So we look at the coefficient of the cubic equation. Our coefficient here is what? Minus 1, positive 4, minus 3, and what? Minus 2. We have applying syntax division. The first rule says drop your first number. So we drop our first number, which is minus 1. The next one says multiply 2 times minus 1 is minus 2. Put up here. So we take the difference, we have positive 2. Again, 2 times 2 is 4. We take the difference, we have positive 1. So positive 1 times 2, we have 2. So the remainder is 0. So the remainder is 0, meaning that 2 hold for this equation. So our remaining equation here is we do a backward substitution. So here we'll have a constant term c, and here we'll have a linear term y, and here we'll have a quadratic term called y squared. So now our new equation becomes y minus 7 parenthesis open y minus 2 plus r parenthesis open. Our first factor here was y minus 2. So we have y minus 2. And our remaining factor is minus y squared plus 2y plus 1 is equal to 0. So we can watch to see if we have a common factor. We realize that y minus 2 here is common. So y minus 2 is common with factor of y minus 2. So y minus 2 is common. So we left with y minus 7 plus r parenthesis open y minus y squared plus 2y plus 1 is equal to 0. We have the equation that says y minus 2 parenthesis open or braces open y minus 7 plus r parenthesis open minus y squared plus 2y plus 1 is closely equal to 0. So we can simplify by saying y minus 2 is bracket or braces, bracket open y minus 7 multiply r in the parentheses. So we have minus y squared r, this time this is plus 2yr, this time this is plus r is equal to 0. Again, we simplify by saying y minus 2, we can group our common variable, meaning that the one that have y, we group y, the one that have y squared, we group, and the one that have a constant, we group. So we will have y squared, so we have minus y squared r, and we have y and y. So we get factor of y, we have 1 plus 2 r y. And we have this and this, which is minus 7 plus r is equal to 0. So we realize here it's a quadratic equation where we have ay squared plus by plus c. So for this case, a here is equal to what? Minus r, b is equal to 1 plus 2r, and c is equal to minus 7 plus r. We can find the root of this equation. So first, we can find the root of this. So we have y minus 2 equal to 0. So it means y will be equal to 2, which is our first root, y equal to 2. Our next root to find the quadratic equation of this complex root, we use the quadratic formula that says y is equal to minus b plus or minus the root of b squared minus 4ac, all divided by 2a. So where a is minus r, b is 1 plus 2r, and c is minus 7 plus r. So the value of b is minus parenthesis will be 1 plus 2r plus of minus the root of. The value of b is 1 plus 2r all squared minus 4. And the value of a is minus r. And our value of c is minus 7 plus r divided by 2 times minus r. So we will have minus 1 parenthesis will be 1 plus 2r plus or minus the root of We simplify this. We have 1 square, which is 1. We multiply 1 times 2r, we have 2r. 2r times the power of 2, we have plus 4r. We square the last thing, which is 2r, we have 4r squared. If we multiply negative times negative, we have positive. So we have positive 4r. Parenthesis will be minus 7 plus r. All divided by 2r minus 2r. Because 2 times minus r is minus 2r. Again, we have minus, parenthesis will be 1 plus 2r plus or minus the root of. We simplify in here, we have 1 plus 4r. R squared, as we said previously, was minus 1. So it's minus 1 times 4 is minus 4. Again, we can multiply by 4. So 4 times 7 is 28, which is minus 28. Minus 28 r. Again, we multiply 4 times r, we have plus 4r squared. All divided by minus 2r. So we have minus parenthesis 1 plus 2r plus of minus the root of. This plus this is what? Minus 3, right? Plus 4r. Minus 4r. Plus 4r, sorry. Plus 4r. Minus 28. R squared is minus 1. So it's minus 4. So we have all divided by minus 2r. So this guy, with this y we find it. So we call the guy y1. It's our first root. So we're looking for y, we're looking for y, we're still looking for y. Who is y2 and y3? We're still looking for y. So we get 1 parenthesis will be 1 plus 2r plus or minus the root of our real number and real number. We add complex number to that complex number. So the real number here is this and this. We have minus 7. And we add the difference here is minus 24 r. All divided by minus 2r. Again, we have this square root, and this square root here is a complex square root, and we need to find the root of this complex square root. So we take this as the root of minus 7 minus 24r. We want to find these roots of this. So to find the root of this is a complex number, right? And we know complex number is, as we say, complex number s is equal to s plus yr, right? We're already using y, so we can also use a complex number z is equal to what? A plus br. So to find the root of this complex number, we can take this root is equal to a plus br. So we take the square on both sides, we square this side, we square this side. So the square we cancel this, we have minus 7 minus 24r is equal to, we square this, we have a squared, multiply this and this, we have a times b, which is abr, multiply by 2, we have plus 2abr. And we square b, we have plus b squared r squared. So we simply have minus 7 minus 24r is equal to a squared. And r squared is minus 1. So it's minus b squared. It's plus 2abr. Again, we group real number and not a real number. We group imaginary number with that of imaginary number. So we will have a real number here is minus 7 is equal to a squared minus b squared. And the imaginary number here is minus 24 is equal to 2ab. So we can make either a or b the subject. So if we make A the subject or B the subject. Let me B the subject. It means that we divide by 2A, we divide by 2A. So we cancel this, we have 12, 2 here 1 time, 2 here 12 times half, minus 12 over A is equal to B. So whenever we see B in this equation, we replace by minus 12 over A. We have minus 7 is equal to A squared minus, and now we see B is minus 12 over A all square. So we got minus 7 is equal to A squared minus parenthesis OB. If we have this as a fraction of the square, we have to square the numerator, and we square the denominator. So we square the numerator, we have 144 all divided by A squared. Based on the denominator, multiply by A. So we will get minus 7A squared is equal to A to the 4th power, because we balance by 1, A squared into this, 1 into A squared is A squared times minus 7 is minus 7A squared. 1 into A squared is A squared times A squared times A squared is A to the 4th. And A squared into A squared is going 1 time. 1 times 44 is minus 144. So we find A. So we have A squared, A to the 4th. We send this across, we have minus 7 plus 7A squared minus 144 is equal to this. So now we can factor. To find the value of A, we can first reduce this to a quadratic equation. So we say let T equal to A squared. So we have T squared plus 7A minus 144 is equal to 0. So we ask ourselves, which number we multiply will have 144 and we have 7. So we realize that we will have 16 minus 9 is 7, right? Yes, now 16 will get 7. And if we multiply 16 times 9, we will have 144. So we can do this as T squared. So 16 have to be the greater number because here is 7 which is positive. So we have plus 16. Parenthesis will be T squared minus 9 is equal to 0. So we have A squared. Replace. You know we see T is what? It's A squared. So there's T, it's T because we factor by this, we get T. So say now we see T replaced by A squared. So we have A squared plus 16. And we also have A squared minus 9 is equal to 0. So we take this as our root to find the value of A. So A squared plus 16 is equal to 0. And A squared minus 9 is equal to 0. So we have A squared equal to minus 16. You have A squared is equal to 9. Remember, if we want to find A for this side, we'll have an imaginary number because our square of minus 1 will give me 9. And of doing this, we always take our positive real number. So here we'll have A to be equal to 3. Because we take square root on both sides, which is A squared. We'll have the square root of 9, which is 3. So A here now is 3. We can find B. So B is equal to minus 12 over A. So B is equal to A is 3, so it's minus 12 over 3. So B is equal to minus 4. Remember, we said that this complex square root is the square root of minus 7 minus 24R is equal to A plus BR. So now, therefore, the square root of minus 7 minus 24 R is now equal to 3 minus 4R. So the square root of this complex root is minus 7 minus 24 now equal to what? Minus 3 plus 4. Our y1, which is our first root, to be equal to 2. And that was our quadratic root, which is our quadratic formula we solved and we got to this. And we realized that we found our complex square root to be equal to 3 minus 4r. So we can continue. We say y is equal to minus parentheses 1 plus 2r. Our complex square root here is plus or minus 3 minus 4r, all divided by minus 2r. We can simplify. We have y is equal to minus 1 minus 2r plus or minus 3 minus 4r, all divided by minus 2r. Because we have plus or minus, so we share this guy. So we have y as minus 1 minus 2r plus 3 minus 4r, all divided by minus 2r. We also have minus 1 minus 2r minus parentheses because we use plus at the first case, we use minus for the second case. So it's 3 minus 4r, all divided by minus 2r. So we can simplify. So y is equal to, we are real number and a real number, so this real to real, we have positive 2, complex to complex, or sorry, imaginary to imaginary, so we have minus 6r, all divided by minus 2r. Again for this, we can simplify minus 1 minus 2r, negative than this is minus 3, and negative than this is positive 4r, all divided by minus 2r. So y is equal to, we can factor us 2. So we have 2 parentheses will be 1 minus 3r, all divided by minus r. Again, we can add real number to that real number. So we add real to real, we have minus 4. We add imaginary to imaginary, we have positive 2r, all divided by minus 2r. Minus 2r. So 2 cancel 2, we have y to be equal to 1 minus 3r, all over minus r, which is our second root, which is y2. So let's keep this first. We have this. We see factor by 2. We can factor by minus 2 instead of keeping the negative. So factor by minus 2. Let's just factor by 2 first. So factor by 2, we have minus 2 plus r, all divided by minus 2r. So 2 cancel 2, we have y to be equal to 1 minus 3r, all divided by minus r. And also we have minus 2 plus r, all divided by minus r. So we can factor by minus 1 in order to get rid of the negative with this. So we have y to be equal to, minus parentheses will be minus 1 plus 3r, all divided by minus r. And also we have minus parentheses will be 2 minus r, all divided by minus r. So this negative cancel this negative, and also negative cancel negative. So my value of y2, which is my second root, is minus 1 plus 3r. And my third root, all divided by r. And my third root, which is y3, is 2 minus r, all divided by r. But remember, from the beginning, we said that z is equal to yr. So we have to replace to find the value of z, because the question was written in terms of what? Z. It was not in terms of y. So we have to carry back to z to find the 3 root of the equation. So z is equal to yr. So mean that our y1 will give us z1 to be equal to yr. So it's 2r. So my first root is 2r. Interestingly, the question says that one of the root is purely imaginary. As you can see, this root is purely imaginary. So my second root is there again. I did not have a root. And there again we have y, right? So it means that if we're going for z, if we're going y2, we have to say z2 is equal to y, which is what? Minus 1 plus 3r, all divided by r multiplied by r. So r cancel r, it means that z2 is equal to minus 1 plus 3r. So my second rule is this. And find a third rule. So the third rule is z also equal to yr, right? So if we're going for the third rule, it means that z3 is equal to 2 minus r, all divided by r multiplied by this r. So r will cancel, so z3 is equal to 2 minus r. So therefore, our rules of the equation, therefore the three solutions are z1 is equal to 2r and z2 is equal to what? Minus 1 plus 3r and z3 is equal to 2 minus r. So we have a question that gives us that says that a complex equation such that one of the equations is purely imaginary. So we realize that z1 is purely imaginary, z2 is equal to 1 minus 2. Minus 1 plus 3r, z3 is 2 minus r. So thanks for watching. It's your friend, your brother Marcus Allen. Stay tuned as we solve more interesting math questions. Thanks.